Hi, VencoreWeather.com meteorologist Paul Dorian here. Well, it's that time of the year again where we like to take a look at some of the factors that could play an important role in the upcoming winter season here in the Mid-Atlantic region as well as the rest of the eastern U.S. Last winter turned out to be a warmer than normal winter in D.C., Philadelphia, and New York City, with temperatures averaging some 4 or 5 degrees above normal for the December, January, and February time period. Snow was quite interesting. It actually increased quite dramatically as one moved northeast along the I-95 corridor. Very little snow fell in and around the D.C. metro region, under 5 inches on average in the D.C. metro region last winter, well below normal. Some 15 inches or so in the city of Philadelphia to maybe up to 20 inches in the suburbs, slightly below normal for the winter season. New York City, however, ended up with 30-plus inches, somewhat slightly above normal for the winter season. So again, snowfall last winter was quite interesting how it really increased dramatically relative to normal from southwest to northeast. Well, one of the first things I like to take a look at whenever dealing with long-range forecasting are the sea surface temperature anomalies. Not only current conditions, but what can be expected over the upcoming winter season, December, January, February, and March. The Pacific Ocean is, of course, very, very important. First of all, it's the biggest ocean by far in the world. And second of all, from a geographical point of view, it's very important for us here in the eastern U.S. because it lies to our west. Weather systems in this part of the world generally move from west to east, so what goes on in the Pacific certainly can have an impact on the eastern U.S., especially during the winter season. Well, one of the most important parts of the Pacific Ocean is the equatorial region, the tropical Pacific Ocean. It looks like we're headed to a winter with La Nina conditions. That's colder than normal. Right now you can see these blues here showing up right along the equator in the Pacific Ocean region. This is South America right here, the west coast of South America right here. All of this blue represents colder than normal or La Nina conditions. Interestingly, what happened this year, early in the year, there were actually weak El Nino conditions with warmer than normal sea surface temperatures in that part of the Pacific. And computer forecast models generally agreed that weak El Nino conditions would not only continue throughout 2017, but actually into the early part of 2018. That, however, changed during the springtime. La Nina conditions developed, and now almost all computer forecast models show La Nina to continue throughout the upcoming winter season into the springtime of 2018, and we'll see some of those model forecasts in a few minutes. Another area of interest, the North Pacific right here, basically sending mixed signals right now. There's pockets of cold right here in blue and pockets of warm. This has been an interesting area over the last several winters. Back in the winter of 2013-14 and 2014-15, there was a very persistent warm blob of water well above normal sitting just to the south of Alaska. In fact, that warm blob of water helped contribute to warmer than normal winters in Alaska those couple of years, and actually colder than normal conditions here in the Mid-Atlantic region for those couple of seasons. The warm blob of water is typically correlated with high pressure ridging along the west coast of Canada and the west coast of the U.S. And when that happens, a downstream trough develops, and that promotes the influx of colder air into the central and eastern U.S. from northern Canada. What happened last year was quite interesting. We had that warm water all the way through October of last year and into November, but then all of a sudden it changed rapidly early in December. Cold pocket of water started to form, and that intensified quickly and expanded quickly, and it turned out that that cold pocket just to the south of Alaska actually persisted through the winter season. And I think that played a role in the warmer than normal weather here in the I-95 corridor. So that's another big factor to focus in on. Also, another area of interest, of course, the Atlantic Ocean. The western Atlantic right here has been, and looks like it will continue to be, relatively above normal. That adds to the possibility of warmer than normal conditions along the east coast, or certainly the southeast coast, Gulf of Mexico, western Atlantic, above normal. So that's another area of interest. So again, we'd like to take a look at sea surface temperature anomalies in the Atlantic and Pacific Ocean. Well, this is a graphic put together by NOAA for the typical pattern during a La Nina winter. Again, odds favor at least weak, perhaps even moderate La Nina conditions in the tropical Pacific Ocean in the period December through March, perhaps even into the springtime of 2018. Typically, a La Nina winter results in colder than normal conditions up to the north and west of the Mid-Atlantic region and warmer than normal conditions to the south and east. Also, the northern branch of the jet stream is more dominant oftentimes in a La Nina winter compared to an El Nino winter. In an El Nino winter, the southern branch of the jet stream tends to dominate, and that in turn helps to fuel some coastal storms. So your biggest coastal storms tend to form during El Nino winters. Now, I'm not saying we're not going to have any coastal storm activity this year or even a blockbuster coastal storm, but the odds are less in a La Nina type of winter because again, the southern branch is not the most active branch typically in a La Nina winter, but the northern branches, and that northern branch tends to bring cold air all the way from Alaska, western Canada, into the northern U.S. Near normal conditions, typically both in terms of temperature and precipitation in the Mid-Atlantic region, but some high-pressure ridging down across the southeast typically brings warmer than normal conditions in the deep south and the southeast U.S. during a La Nina winter. Well, in terms of the confidence of a forecast for La Nina to continue through the upcoming winter season, and again, we already saw the current conditions certainly show La Nina conditions in the equatorial Pacific. This is a compilation of many, many numerical models that almost universally forecast La Nina to continue into the winter and the spring of 2018. This line right here represents neutral ENSO conditions here. Anything above El Nino, anything below La Nina. This is rolling 3-month averages right here. For example, January, February, March, right in this region right here. So this area right here represents the average expected by these computer forecast models for January, February, and March. We go from weak La Nina basically down to weak to moderate La Nina. The yellow represents the average of all these models. So again, very high confidence that La Nina will continue in December, January, February, even into March. By perhaps the middle of next year, it'll get back to neutral according to these computer forecast models. So again, models certainly support the idea for a La Nina winter. Well, I want to now focus on two particular model forecasts for sea surface temperatures for the upcoming winter. By the way, all of these maps I'm showing during this video discussion are posted on the weather website in the 2017-2018 Winter Outlook blog. This is from Japan's meteorological agency known as JAMSTEC. It is pretty reliable for sea surface temperature forecasts. This most recent forecast from the early part of October. Two areas of interest. Blues showing up right here in the equatorial part of the Pacific Ocean. In other words, the JAMSTEC model is predicting La Nina. Notice in the North Pacific a mixed bag of colder than normal here represented by the blues, warmer than normal just to the south of Alaska represented by the reds. Again, a mixed signal in the North Pacific, but certainly supporting the idea of La Nina in the tropical Pacific. And notice also along the western part of the Atlantic Ocean, warmer than normal conditions depicted here by the Japanese computer forecast model. Well, here's a look at NOAA's climate forecast model known as the CFS-V2. It too has La Nina conditions. This is for the December, January, February time period. La Nina in the tropical Pacific and virtually normal conditions here in the North Pacific. So again, mixed signals from the North Pacific, but La Nina is standing out here in all these computer forecast models, and lots of warmer than normal conditions here in the Western Atlantic. So these models agree with each other, and they pretty much agree with almost all models out there right now for La Nina to continue. Nothing dramatic in the North Pacific, mixed signals here, neutral conditions there, or some pockets of cold and warm, but warmer than normal in the western Atlantic as well. Well, in addition to looking at sea surface temperature anomalies, I like to take a look at what I call analog years, going back 50 or 60 years or so, to look at prior winters that may have had similar conditions to what is expected this winter. You're never going to find an exact match, but first of all, I selected La Nina winters in years past, but I also filtered out those La Nina winters that were preceded by inactive tropical season in the Atlantic Basin. We had a very active tropical season this year in the past several months in the Atlantic Basin. So my analog years are La Nina winters that also were preceded by an active tropical season. And this is the temperature anomaly pattern average out for the December, January, February, and March time period for those particular analog years. Temperatures on the left here and the precipitation on the right. And notice, pretty similar to your typical La Nina winter, these analog years had colder than normal conditions to the north and west of the Mid-Atlantic region and warmer than normal in the deep south to the southeast U.S. with near normal conditions right here in the I-95 corridor. Also, precipitation-wise, notice a band of near normal right here, right along the immediate I-95 corridor here. Places like D.C., Philadelphia, New York City, near normal for these particular analog years. Again, supporting the notion of a near normal temperature pattern this winter here in the Mid-Atlantic and a near normal precipitation pattern in the Mid-Atlantic region here. A little bit wetter than normal shown on this map by the blues here to the north and west of the big cities, in the mountains, for example, of central and western PA, and a little bit drier than normal along the southeast coastline and in the interior part of the southeast U.S. Well, one important factor during the winter season is whether or not there are high latitude blocking events. This is a phenomenon that occurs when there's abnormally high pressure during the winter season over places like Greenland, Iceland, northeastern part of Canada, and it's really a requirement in most cases for snowstorms to occur in the big cities of D.C., Philadelphia, and New York City. You really want to have high latitude blocking, high pressure stuck in place over those regions. Without a high latitude blocking, you certainly can get cold air outbreaks into the northeast U.S. However, they typically will come in quickly and leave quickly. And if you have a coastal storm, for example, you may have a scenario where it's snow quickly changing over to rain. But if high pressure is locked into place over Greenland, over Iceland, what it tends to do is it acts to displace cold air masses from the higher latitudes into the middle latitudes and into the northeastern U.S., for example. The cold air outbreak by itself is important, but also whether or not that cold air is sustained is very important. And that's when we look to whether or not high latitude blocking is taking place. Well, there are three different things I like to take a look at this time of the year in the fall season to give an idea as to whether or not high latitude blocking is a likelihood for the upcoming winter season. The Arctic Oscillation Index is an index meteorologists track that gives us an idea as to what the pressure pattern and temperature pattern is up in the North Atlantic, and that in turn is correlated with high latitude blocking. When the Arctic Oscillation Index is negative, it tends to be correlated with high latitude blocking. And studies have shown that if the Arctic Oscillation Index is largely negative in October, it could be largely negative during the upcoming winter season. In other words, a lot of high latitude blocking events, a lot of cold air intrusions that stick around in the northeast U.S. Well, here we go. For the month of October, the Arctic Oscillation Index was largely neutral to positive, not a bullish sign for cold air outbreaks to be sustained in the Mid-Atlantic region during the upcoming winter season. The reds here actually represent the forecast over the next couple of weeks. The blacks, the actual observed. So again, throughout the month of October, the AO index has been neutral to positive. Going forward, by the way, it does tend to slip down into negative territory. Sure enough, that's foretelling, I think, some cold air outbreaks coming into the eastern U.S. by the early part of November. It looks like we're going to start off with a couple of cold weeks in November, at least a couple of cold weeks in the central and eastern U.S. But in terms of the upcoming winter season, this is not a bullish sign for high latitude blocking here in the mid-Atlantic region. Now, I mentioned there were three different things I like to look at. A second factor here is the snow accumulation during the month of October in places like Siberia. Research studies have shown, especially by meteorologist Judah Cohen, that if there's a substantially increasing snowpack during the month of October in places like Siberia, that tends to increase the chances for high latitude blocking events during the upcoming winter season, which in turn leads to cold air outbreaks in the eastern U.S. Well, this is a comparison of the snowpack in Siberia at the beginning of October right here versus a couple of days ago on October 23rd, and certainly there has been a significant increase. However, I will say that it's not quite as dramatic of an increase as has occurred the past couple of winters. So all in all, this is maybe a neutral to a slightly positive signal for high latitude blocking for cold air outbreaks into the eastern U.S., whereas the Arctic Oscillation Index was definitely not at all a positive signal. This is maybe neutral to slightly positive in terms of the likelihood for high latitude blocking events. Well, one final factor that does seem to play a role in the frequency of high latitude blocking has to do with the sun. And we all know the sun is most important, the driver of all weather and climate, especially in the medium and longer range, but even in the short range. Studies have shown, and empirical observations have shown, that low solar activity winters tend to be correlated with more frequent high latitude blocking events. This certainly looks like a low solar activity type of winter. Not only are we headed now towards the next solar minimum, well past the solar maximum phase of the current solar cycle number 24, but this particular solar cycle is historically weak, one of the weakest in 100 years, perhaps even longer than that. So there's no doubt in my mind we will have a low solar activity winter. That tends to be correlated with abnormally high pressure. What we're looking at here, this particular map, is a compilation for the winter season of 500 millibar height anomalies. And what we see here is for these low solar activity years, there happens to be a very strong signal showing of higher pressure than normal, higher heights than normal over places like Greenland, northern Canada. And again, that's associated with high latitude blocking events. Colder air intrusions have a chance to be sustained into the northeast U.S. All of these low solar activity years are associated with solar minimums. And again, this looks like a low solar activity type of winter. So this is a bullish sign, a positive sign for high latitude blocking, which in turn is a positive sign for sustained cold air intrusions into the Mid-Atlantic region during the upcoming winter season. Well, all of these factors lead to what I believe will be a near normal type of temperature and precipitation pattern for the upcoming winter season here in the Mid-Atlantic region. What that means more specifically is plus or minus a couple of degrees in terms of the average temperature in the December, January, February, and March time frame. Certainly we'll have some cold air outbreaks, and certainly we'll have some snow. And by the way, this looks like it'll be colder than last winter, and certainly parts of the I-95 corridor more snow than last winter, especially around, for example, the DC metro region. Near normal snowfall amounts, well, that's typically 15 to 20 or a little bit more than that in the DC metro region, maybe 20 to 30 inches in Philadelphia, 25 to 35 in New York City, all outlined here on our blog, which is posted now on the weather website. Again, basically these factors, too many mixed signals for anything extreme this winter, pointing me towards near normal conditions for temperatures, near normal conditions for snowfall amounts in the I-95 corridor. Again, a La Nina winter. And it looks like it'll, as typical for La Nina winters, colder than north and west, of the Mid-Atlantic, warmer to the south and east, and somewhere in the middle in the I-95 corridor from D.C. to Philadelphia to New York City. So we'll certainly update this as the season progresses over the next several weeks. But that's it for now. For VencoreWeather.com, I'm meteorologist Paul Dorian.